Hello, I'm Daniel Goldman, co-owner and industrial designer here at MSB Technology, and today I'm joined by
Frank Vermeulen, and I'm the European Sales Manager for MSB Technology.
And today we're going to take a look at the Cascade DAC, our newest entry on our product list. And we're really excited to share some of the features that come with it. And Frank and I are going to do a little bit of a Q&A as we discuss the product.
Fantastic. So Daniel, you came up with a completely new product here. Where did the idea come from?
So at MSB, a lot of our products are iterative designs. So we kind of evolve products from year by year. With the Cascade, this is kind of a ground-up foundational redesign where we're able to really change up a lot of things. But just looking at the product, you're going to recognize a lot of our design methodology and a lot of features that you can recognize from previous products like the Select and Reference DAC.
Wow. So we have 3 chassis and I see 2 power cords. So what are they?
Yeah, so we have a 3 chassis design now. Fundamentally, we have each chassis serving very specific purposes. And with this redesign, we were able to separate digital from analog in ways that we've never done before. So the digital director was our first step towards this kind of technology. And with this product, we've been able to take it even further by removing all processing out of the DAC unit. So starting on the top here, we have our all-new digital director for the Cascade. So this now incorporates the LED display, controls, and all processing of the digital signal. And then in the center here, we have the DAC chassis. So this has the DAC modules, but it has no digital processing. It also has no digital power supplies. So everything is prepared in the director before arriving at the DAC. The DAC also includes a newly redesigned preamp input. We have 2 RCA and 2 XLR analog inputs. And then lastly, we have our new power base, which again is a ground-up design with all analog power supplies that powers just the DAC chassis. So you can actually take this digital director away from the system, isolate it, get all that noise from digital noisy inputs, and separate it from your analog system entirely.
Wow, so that means the customer now can easily hook up a reel-to-reel, a turntable, another analog source, and still have 4 digital inputs, or 5 if you use coaxial optical. Wow.
Yeah, we were able to carve away a lot more space in this new design since the DAC has such a dedicated function for the DAC modules that we're able to make much larger preamp with more power filtering, better power supplies, and just generally a much higher end product to match the level of our digital converters.
Wow, I think it's fascinating. If I look at it, the metalwork feels different than what I know from the Select or the Reference DAC. So is this a new finishing tool that you have, or?
Yes, so this is actually a new anodizing finish as well. We have been reinvesting a lot of our profits back into the company over the last few years, creating a manufacturing line that will be able to produce products on a much higher level than we ever have. So we recently purchased a machining center that's made by Grobe. It's a 5-axis, German-made, very high-precision machine. And we're able to machine these chassis in such a way that we don't have to do any hand finishing. This is straight from the machine to the finisher.
Wow, it looks fantastic.
Yeah, we also are able to incorporate a lot of very fine details with this new chassis work. So you can see in here how this kind of blends into the heatsink. You can see almost the chassis within a chassis. These foot protectors here are replaceable. So down the line, if anything happens when stacking products, we're able to remove it with hidden hardware that comes from below the product. And then there's just a lot of really nice fine accents and details that are crisp, clean, and really highlight the efficiency and precision of this new machine.
Wow. So Daniel, I see there's a completely new display. It's big, but it's not as big as the Select, but it's much bigger as the Reference DAC, and it has all the information. Where did that come from? I mean, it looks great.
Absolutely. Yeah, this new display is designed for efficiency in manufacturing. We didn't make any compromises with the information. You've got your full large volume control characters still. You have your input information, video mode, for low latency, for voice syncing, and phase invert. All that information is still visible. Menus are fully browsable, and so you can go in and change settings. But one of the efficiencies that we were able to incorporate to help bring that price down is the way these are manufactured is reel to reel of the actual LEDs changes slightly. So you can't start making a board, fill it halfway, and then switch reels and continue. And the way the Select was designed, it used 2,096 LEDs. So you get 4,000 LEDs on a reel, we got 2,000, and then we had to fill the rest in with 96. So it's very inefficient. But with this one, we've designed it to specifically get 3 displays per reel of LEDs, which dramatically improves the yield in the materials from the manufacturers.
Wow, fascinating. How you do like lean manufacturing, optimizing the process. The chassis is, I think, as wide as a Select, but it's less deep. Is that because you could fit all things more condensed in the chassis, or was there also a format?
Yeah, so vertical integration is one of our priorities at MSB. So we spend a lot of time getting to know the manufacturing, and the reason for this change in the chassis size, just bringing it just almost 2 inches narrower, is we actually get to increase the yields from the plate coming from the foundry. So those foundry plates are coming in at 48 inches, and with the Select, we were only able to get 2 plates out of that cut. And by reducing that just slightly, we're able to get 3 plates for the same amount of source material. So that efficiency really comes through when we're trying to create so many chassis.
Wow. So this is like the next step in digital audio.
Yes.
Because I was listening before in the listening room and dialing in the system, and I did that first with the Select and then compared this product, and the natural sounds, the harmonics, the texture, the flow, the pacing, the rhythm, acoustic information from the recording, it was really, really, really good.
One of the aspects is with this digital separation, something we got a taste of with the digital director, but with this refinement is just brought to a new level, is lowering that noise floor to a point where you can hear those fine details that create that realism, that create that space that you're able to actually experience now.
I see a complete new power connector in the back from the power base and the DAC preamplifier.
Yeah, so before we had 2 power bases for the Select. One of those was your analog power supplies, and then we had a digital power supply. So you had 2 cables, you had that isolation and separation. But with this product, since we've taken all the digital out, we've eliminated all those digital power supplies for the DAC itself. So instead of having 2 separate cables, we now have this new cable. It's called our Summit Series power cable. And this has new Fisher connectors that we're getting ordered just for this production, and just a beautiful fit and finish, but also, Swiss performance, incredible contacts. It's just a new level of performance, because everything about this product demands our best. And this is one of those areas we've made a big improvement over previous generations.
Looks great. The digital part still has the input modules as we know them today. So that means existing modules can be reused. We don't need to switch anything there.
Yes, yeah. This will be completely compatible with all of our discrete, Premiere, Reference, and Select input modules. So anyone with renderer, USBs, Pro USBs will be able to migrate those over.
Great. And then you have the glass fiber connector as we know it with the Director now. But then between the digital part, so we have galvanic isolation.
Correct.
Between the DAC part and the digital part.
Yep, and with those fiber connections, we're able to separate these digital sources even further from our systems, bring it closer to the user, closer to the listening chair. So as you're experiencing that music, you don't have to have this putting all of that digital noise even on the local power connections to your amplifiers or DAC.
Fascinating product. And there is this little curve that goes around.
Yeah, this is one of those beautiful touches that you might not, notice how it's manufactured because it's so seamless and there's no lines that are visible. But this is actually made on our 5-axis machine with a lens cutter, which is a high radius. It's like a 20-inch radius. And it's just a portion of the radius, and that comes in contact at an angle and curves across the top of the chassis over and over again, several hundred times, to get a beautiful, beautiful finish that's perfectly smooth. And that's one of the only ways to do that is with the precision machines like Grobe.
Wow. This runs so much smoother than the one from the Select. How did you get there?
We've got some new bearings in here with some very high quality grease that help dampen the ball bearings as they're in there, so there's no rattling, there's no like metal on metal sound. It's just very, very smooth, very silent. And we still have the magnetic detents that we have in all of our products. So once you turn the knob, it'll auto switch back to a fixed position, so your volume is never flickering between two volume steps.
Wow. And then these buttons, they look a little bit bigger, the button.
Yeah, so we've got a slightly larger button, but you'll also notice we just have more lathe round parts on this chassis. We've got a new lathe automation solution with a robotic arm that is now handling all of this automated. So we're able to make more of these parts, and the robot is able to remove them from the machine piece by piece, protecting them from each other so we're getting no blemishes. You know, traditionally with a lathe, it finishes a part and then it puts it into a bin, and the parts will bump together and cause havoc. But with our new robotic solution, we're able to manufacture these, very efficiently, around the clock, overnight, very, very long production runs, and just have the best fit and finish for this application.
So this is going to be the new era in digital reproduction, or digital to analog. It's fascinating, the technology in it. Are there any changes in the DAC modules itself, or is it still a similar DAC module as the actual Select and Reference?
So this actually has the same hybrid DAC modules as the Select. So it has 8 of those DAC modules, which are both balanced design. So that's 16 DAC channels, but we're using them in a completely new way. We're able to really harness the potential of those modules in new ways. With the new processors and the digital director, we actually prepare the data streams and send them prepared over the fiber connection so that when they arrive in the DAC, they're prepared for each DAC module in advance. So we're not unpacking the data, doing any processing in the DAC itself. And that has yielded just incredible results, as you've heard.
Yeah, so basically the digital noise that still would, in a very low level, be in the Select or in the Reference DAC, because you had the signal arriving and then you had the last processing part before it went into the DAC modules. You got that in the front here in this beautiful first part of the DAC.
Yeah, we've been able to migrate all of that over, and that's really made an improvement. Because with digital frequencies, like processing is such a high frequency noise, it's really hard to manage and control. And no matter how much shielding you do, there is no substitute for distance. And with this, separating it to a separate chassis is just unbeatable.
I see you have silver with a silver matte color. Are there any other colors possible? Like, if it's black, is it the black going to be silver, or is it going to be black? Or
so with this series, we have a lot of accent pieces that you've seen. And if you look behind you on the rack here, we've got the black version, and it's got these silver accents as well. So the stock basic colors that we want to ship are going to be silver and black with stainless. Just the raw stainless finish is very authentic. It's very honest. We're not covering it up with anything, but we do have options to add, some personalization by changing the finishes of the stainless. So we're going to have options for a matte gold, a matte copper, matte black, and matte silver. A lot of people have all matte black systems. They just want it very muted. We'll be able to do that and accommodate it.
And if we have like a customer with a D'Agostino amplifier, we can make these
exactly
bronze
do the matte silver chassis, which will be, you know, our stock finish, and then add copper accents to match. And
Wow.
I think we can probably continue to add more finishes as we find demand and see what people are interested in. But we do want this to feel like it fits in the system, that, you know, the identity of what has been crafted matches and really highlights the customer's vision of their own system.
Wow. The anodizing is still in California?
Yes.
Okay.
Yeah, we have a local shop that we're working with that does all the anodizing in-house. Everything here manufactured under our roof or locally here in California. These blocks of aluminum come from North America, up at the border by Canada, Niagara Falls. They use the hydroelectric to power the creation of the metal. You know, locally sourced, vertically integrated manufacturing. We're doing everything we can to bring it in-house, control the process, but also by doing that, finding ways to improve the process and improve the product, and then pass on that technology to our customers.
I noticed in the factory are some new machines to make the boards and do the soldering, and it's fascinating because Jonathan told me about the reliability that it creates. Can you tell a bit more about that part?
Yeah, so we have our own SMT circuit board manufacturing line in-house. This is a process that these product lines will make hundreds of thousands of circuit boards. You know, usually you don't bring those processes in-house for a smaller manufacturer because, you know, it's millions of dollars of equipment. But with us, we make electronics that have to sound good. And every variable we can control helps us on that journey. And with the SMT, we would send these boards out and they would get assembled. But like, we couldn't control the temperature profile of the soldering. We couldn't control the reliability of how the parts were applied. We couldn't control, you know, all of these little errors that we would eventually have to find out, test, and it would reduce our yields. So when we made DAC modules, we would actually send them out, get them made, and then we'd bring them back and measure them, and we'd have to grade them, and we'd have to throw away, you know, 30% or something like that. And then that makes all the other ones cost more because we don't have a good yield. But with our in-house SMT line, we've brought our yield up to like 98% because we can control these variables.
Mm-hmm. So you're improving the reliability, you're creating a more consistent production so that every product will exactly sound the same because they're produced the same way. And also the lifetime, because when you're creating this soldering process, you don't get a huge temperature increase where smaller parts may get like overheated.
Exactly. Yeah.
And you're keeping it much more stable.
And the most important is performance, better performance, you know, just that comes with all of those other variables.
Good. Wow. So improved reliability, new design, separation of digital and analog. I'm intrigued to see what's in the box.
All right. Well, let's take some covers off and take a look because these are packed and I'm excited to show you what we have under the hood.
Good.
All right. So we've got the digital director open, taking a look at the inside here. So just right off the bat, we have our base metal, which you have seen this finish before in our products. It's almost looks like raw metal, but it's actually an allodyne surface. It's like a electrically conductive surface because aluminum unfinished will actually become an insulator. So chassis like this that are anodized are insulators. So this is not conductive. So if you look closely at the details like these screw holes, you'll see they're shiny inside them because we've actually masked them off and allodyned them with this same finish on the inside. So the importance here is having this base connect here and be, you know,
Have like the ground connection.
Yep, with the chassis.
Through the chassis. So we see the input modules here connecting, and then we have a processor.
Yeah, so this first stage, as we come from the input modules, is actually going to select the input module you want to use and turn off the other ones that you're not using. So if you have 4 different digital inputs, we can isolate the one that we're using and disconnect the rest and not worry about that extra noise coming into your system. And then the signal path goes from there through these other processors, which are all programmed in-house for decoding the information, putting them through their digital filters, and taking the signal from literal zeros and ones to an actual signal we can use.
If I look, there are little lines that are the electrical conductive lines going through the things. They're all almost like mathematically, geometrically symmetrical next to each other. It's fascinating to look at it, how they create a short path.
You're noticing an interesting design cue that we do with our signal traces is much like a running track, the inside track is actually shorter than the outside track. So when you have multiple signal traces going on a circuit board, when you do a turn, that inside trace is going to be shorter. So you see some clever geometries to make those signal paths the same length. So especially with this kind of information, we really want everything arriving in sync.
Yeah, so you have electrically exactly the same length in your...
Especially when we get to the analog signals, where the actual traces themselves are, part of the signal path.
And then here, I see one line going to the Pro ISL connector to have the glass fiber connection to the outside.
Exactly.
And then we have two big connectors here that go here.
Yeah, so these two connectors are two separate connectors. One is for power and one is for signal. In the chassis, we have our incoming AC power, and you'll notice we have the two separate boards here, and the transformer is in between them, and the signal path is in between them. So this here is your incoming AC. This is your standby transformer. This is where you're looking for power, automatically switching between 120 or 220 volts. We have a ferrite here right in the wall, and then all of these walls are helping block that noise and that radiation coming from the circuit boards. And then this is where we're doing our power filtering and refining the signal to the usable power.
Wow. So you see this is where the modules are, so we have a little clip here. Why is that there?
So these are springs to apply pressure to the modules. So our modules are actually removable without any tools, and it's a cam system. But because it's a cam system, we need to put some tension on that cam, otherwise it can loosen itself. So you'll also notice in the front here, we have this display pocket. Again, we're using the unibody design to create these isolation barriers between noisier electronics and quieter electronics. So the display is an array of LEDs, can be quite noisy electrically. So this is in a separate isolated pocket with this wall here, data connection here, and a ferrite on that data connection. So we've done everything we can to isolate that. And the cover actually comes and mates with this groove so that you have a very secure connection and no radiation coming into the chassis.
Fascinating. So this is the director part with the volume control, well, the knobs for the volume control, because
Yep.
I don't see like a volume control part in here, so that will go through the ISL connector to the analog part, and that's where the next step is happening. Shall we take a look at that?
Yeah, let's take a look at the DAC. So, well, now we've arrived at the DAC. This is kind of the heart of the system. We sometimes call it our digital engine, because this right here is the magic. This is what's making music from those signals. The basic flow of this unit is you have the Cascade Link, which is the fiber cable coming in this side. Digital signals arriving at the DAC modules on this end, going through the ladders, coming out on this end, and then they cross over to our preamp. So our preamp is in this direction. It's attenuation based. We have a lot of power coming through this DAC design. So we don't have to come out, there's no op amps here. We're not boosting the signal, but then we come through our preamp here, and we have added these analog inputs that come through here that do require op amps because of the different signals coming in. And then they come around to the same chain of command here.
Yeah, so we have the Pro ISL input here, the link coming from the director part. The distribution, that left 4 modules for left, 4 modules for the right, and then we have the Femto 33 clock.
Yeah, so we're still
Clocking
using the Femto 33 clock in this design. We have a slightly bigger footprint for future clock designs if that is something that happens, but for now we'll be using the Femto 33. And similar to the Select and Reference, we have placed the clock right against the DAC modules. So this is keeping your clock signal the shortest path possible,
Yeah.
especially as you're trying to combat jitter in a digital system.
And then we have here all different little power supplies to separate every step.
Yeah, we've separated all of the power supplies to the different devices because if you sum them all together and put them through the same filtering, you're going to add up all the noise from all those different processes. So by doing this, we're able to take that noise floor down another level there.
Wow. So taking the noise floor down, separating analog and digital, and then going out to the amp through the volume control.
Yeah, and as I've said, we've used every inch of everything in this design. So this is a lot of electronics on the base metal, but we didn't waste the chassis. So if you look over here, we've got a couple things going on that are quite interesting. Is this channel here is our preamp. So you'll notice these track this here. So these walls actually come right down to the circuit board, and we have barriers on the circuit board to protect the signal as it goes through these preamps. When the signal comes out and is analog at this point, it's very, very sensitive to any kind of noise or interference from other devices. So we protect that signal as best we can by bringing this, level of EMI wall protection in place. And you notice in the back here we have this wall as well, which comes down behind our incoming connectors, all of these holes that have been cut in the electronics.
Wow. And then you have damping material for the clock,
so this
for
is
the modules.
a thermal connection, this gap pad that connects to both ends of these ladder decks to keep them thermally stabilized on the chassis for best performance, because you don't want those temperatures moving around.
No, and if I understand correctly, the metal housing of the DAC modules actually also helps to stabilize the temperature and have a very evenly temperature in all the resistors.
Yeah, everything in there is heat sunk to the chassis itself, which is why we make those. Yeah, there's a lot of clever tactics that have been employed to make this perform and manufacturable, and just even being exposed to it for as long as I have been, I keep looking at it and just you see these small details where you've just got all of this electronics cleverly tucked away, efficiently designed, and brought into this compact design to reduce noise and exposure. If these were all separated into separate components, you're sending these delicate signals over cables, over connectors. So keeping all of this very compact and very tight, like this flow comes in, around, directly out. It's just the shortest path possible, priority on performance over anything else.
Wow. Yeah, fascinating how this little curve helps to pick up the product and gives it a smooth feel. And then the heat dissipation, the surface that you create here is ginormous.
Yeah, it lets that air intake from the outside, especially if you have this unit on a flat shelf. If this was too low to the ground, you're not going to get that airflow. So we've contoured the edges of the heat sinks to open them up a little bit. Well, I think the next thing to look at will be our power base for this system.
Yeah, because if I look at all the separations that go in there, that power supply must be something really special.
Yeah, we're pretty excited about this one.
This was a heavy piece to bring in.
Yeah, it's probably the heaviest chassis out of the bunch. If you're familiar with our previous products, you'll notice we have a lot more going on in this power supply. Also, because of it being a dedicated analog power supply, it's again where we're able to take that technology and make it much more focused on what we're doing. So here we have 5 power supplies total, 2 on this transformer, 2 on this transformer, and 1 dedicated on this transformer. So this actually handles the power for the DAC modules. So it's completely dedicated for just that purpose, as that's, again, where the signal is the most sensitive. But you'll also notice in here, we have this new power filtering, power conditioning section on our power base. Power grids are getting dirtier and dirtier. And, that was sort of the spark of inspiration for the digital director. But we can't ignore that as we design new power supplies. And so this has done some pretty amazing things for our measurements and bringing that, again, that noise pollution down as it enters the system.
Okay, so we have in the Select, previously we had like 3 transformers, but these are now double, so we're kind of like reducing the amount of.
Yeah, and in the Select, you also had to have more power supplies for the digital side and the digital processing. And so this is really just like if you almost imagine one Select power base instead of two, because it's just focused on the DACs and the preamp.
Yeah, that's right, because we have the power supply from the director part with the display that has its own digital.
Yeah, so that has its linear integrated power supply dedicated to the digital side, and then this is dedicated to the analog.
So here we have 5 parts for different sections in the preamp, the volume control, the ladder DAC modules.
Exactly.
Wow. And then we have grounding the chassis.
Yep. A ground, and then over here we have a shield. So this connects to the shield of the cable in between the two. So it's to help prevent any noise from entering the system through the cable.
Okay, that's smart.
You'll also notice some cool details. I don't know if you've ever seen this on any of our products, but see that cutout around those chips? So that cutout is so that as the temperature of the board changes, we don't want it to stress those components because they're very sensitive. So by leaving it on this tab, the circuit board isn't pressing and distorting the performance of those chips.
Wow. In the back, I see that we have again the 12-volt trigger function.
Yeah, so this is a 12-volt trigger we use for controlling the power of our amplifiers and DACs. So it's a way of syncing up our products together so that you're not having to go along and press 4 or 5 power buttons, or if you use the remote, things don't get out of sync. So yeah, if you look here in the front, we have our power front control, so we have a power button on off, but then we also have 2 controls here. So one of these is a wheel for the brightness of the LED, and then we have a switch here that toggles between modes. It's basically a master or slave power control. So if you leave this as the master and then put your amps in the slave mode, connect them with the 12-volt trigger, then you press one button, the whole system turns on. And our amplifiers actually have a time delay option, so you can set time delays so that if you have 2 of the M500s which have a pretty big inrush current, they don't start in parallel together, but instead you can delay them by a couple seconds so that you're staggering those startups.
Yeah, so that makes it also a product that can be used when somebody wants to integrate this in a custom install high-end audio system with a client that is like, okay, but I want one button on, and you can integrate all that and automate the process without having crappy quality.
Exactly.
This is the way to go. And this is the metal finish you talked about to protect.
Yeah, so now we're looking at the outside of the product. So before we were kind of looking at the inside finishes, those machine lines, but this is a texture we put on all of our covers. A nice diamond pattern. It's a little more durable, a little more scratch resistant. And you can see here we're matching these contours with the chassis itself. Just every little detail possible to make things as beautiful as possible.
Wow.
Well, thank you guys for watching. It's been really fun kind of discussing and sharing this new product with you. It's fun to talk about, but it's a lot more of an experience to hear it. And we're going to get that first production rolling through the factory, hopefully get some units out for demo, get some dealer events going, because we want people to be able to hear this, and just so very excited for what we've come up with, and want to share that with you as well. So thank you for watching, and we'll see you in the next one.